So last round of word problem proportion. So again, remember we're trying to set up a fraction equal to a fraction, labeling your unknowns, and be careful about who's up in the numerator and denominator. Just be consistent. So in the next one, we have a recipe for spaghetti sauce requires 5 16-ounce bottles of ketchup to make 3 gallons of sauce. Right? So like maybe they have a big party or something. How many bottles are needed for 7 gallons of sauce? Alrighty, so it looks like what we have, if we take a look at our comparison, we're comparing bottles to gallons. So perhaps when I start setting up my fractions, I set it up as bottles to gallons. Of course, if you want gallons to bottles, you could do that. But whatever you decide, be consistent. My unknown in this case, we're looking for how many bottles for 7 gallons. So how about we call that X, right? So bottles for 7 gallons. What do we know? Well, it takes 5, right, bottles to make 3 gallons. So there's one of my fraction. 5 is to 3. So again, this is 5 bottles for 3 gallons. And so what about if I have 7 gallons? How many bottles do we need? I don't know. So we call that X. So there's your setup. Bottles to gallons, bottles to gallons. I have my unknown. To solve, we cross multiply, and we get 35 equals 3x. Do a quick division, and it looks like x is 35 over 3. And I think 3 goes into there, 11 times with remainder of 2. So how many bottles will we need? 11 2/3 bottles. Of course, maybe at the store we actually buy 12 and we just don't use 1/3 of the other, or whatever the case might be. But there's the problem. So 11 2/3 bottles are needed. And so again, you see I'm setting up a proportion. I'm careful about what's in my numerator and denominator and matching it in the other side. I'm labeling my unknowns, creating the same number of equations that we have, in this case a proportion. Solving it using cross multiplication, which is nice and easy. So the next one, we have a sample of 30 spark plugs, and 2 were rejected because they were defective. If you are holding 5 defective spark plugs, how large is your sample? Alrighty, so again, X is basically the sample, right? Total sample, if you would. And what we know, right, is that a sample of 30 contains 2 rejected defective spark plugs. So how about I put the total down on the bottom and the defects up on the numerator. So this first information gives us the fraction 20 over 30. Of course, in the next one, I'm holding 5 defectives, and I have an X amount of them. So there's our setup, all right, defective to total, defective to total. So cross multiplying, I believe 30 times 50 is 150, and we get 2x. Divide both sides by 2, and we end up with 75. So there are 75 spark plugs in my total sample if I'm holding 5 defective ones. So hopefully you're starting to see how that works. Next example is also kind of a real-life example. Biologists do this when they're trying to predict the population of some sort of an animal in an area. They actually go out and tag them and do exactly what you're seeing here. So let's investigate. So a biologist catches and tags 20 rainbow trout in Tesuque Lake. 2 weeks later, the biologist goes back and catches 9 trout, and 6 of them have tags. Estimate the total population. So again, there's a lot of assumptions here. We're assuming right now in the lake, right, in the total population, there are 20 tags out there. All right, and so maybe I put tag fish over total. So we know, right, from this guy that there were 6 tagged fish out of 9 total fish. So out in the lake, there are 20 tagged fish for an X amount of total fish. And so there's basically our estimation setup. Cross multiplying, I believe we get 6x, and 9 times 20 is 180. Divide both sides by 6, and I think 6 goes into, it looks like 30. So this based off of the information and the data that he's given, I would estimate that there's 30 rainbow trout, right, in this lake. So possibly it's a pretty small lake. Who knows? All right. But there's basically your word problem setup. Again, we're setting up a proportion. Be careful, be consistent about what you put in the numerator and the denominator in each case, and just make sure your other side matches what you have on the one side. Most of the time you'll have one unknown. All right, so label it, set up your equation, solve by cross multiplication, and get your units right in the end. Are we talking bottles, spark plugs, trout, hours, whatever the case might be? That wraps up chapter 6. And onward and upward, we got to move all the way to chapter 10. See you guys in those new videos.